right, so this is the last little bit of yesterday's lecture notes on polygenic traits. So polygenic traits are traits that are affected by a number of genes, okay? It's more than just big A, little a. Could be big A, little a, B, C. It requires multiple things, okay? So instead of just showing up as yes or no, it shows up as a graduation of small differences. Many normal human traits are thought to be polygenic. For example, hair color, eye color, weight, height, skin color, right? It's not like you either just have black hair or blonde hair. There's a variation of hair colors in between. So that means it's definitely polygenic. All right, sex determination is something we haven't really talked about too much yet. So the human cells contain how many pairs of chromosomes? Do you guys remember? Yes. Oh my God, I love it. 23 pairs or 46 chromosomes total. There are 22 pairs of autosomes, which are like your normal chromosomes, and 1 pair of sex chromosomes. The sex chromosomes determine your gender that you're born at birth. In males and females, all the pairs of chromosomes are exactly the same except for 1 pair. The pair that are the same are called autosomes. Okay? Autosomes are all of the chromosomes within a cell except for your sex chromosomes.
What is that serotype? The chromosomes?
One pair that differs between the males and females, this pair is called the sex chromosome, and the sex chromosomes differ in structure. Females have 2 copies of a large X chromosome, and males have 1 X and 1 Y. A small Y. The Y is probably half the size of the X chromosome. Yeah. So sex-linked genes. There are many genes found on the X and Y chromosome. Okay, well, there's a lot more on the X chromosome. The Y chromosome appears to only contain a few genes. But there are genes that you inherit from your parents that are on these specific chromosomes. Right? We learned all about the chromosomes when we were talking about meiosis. And it goes under division twice, and it makes the 4 gametes, okay? So since the X and Y chromosomes determine the sex of an individual, all genes found on these chromosomes are said to be sex-linked. So if it's a gene that is on your X chromosome or your Y chromosome, we call it sex-linked. Because it's a trait that is also linked to what sex you will be born as, right? More than 100 sex-linked genetic disorders have now been associated with the X chromosome. And sex-linked traits include color blindness, hemophilia, muscular dystrophy, male pattern baldness, you name it. There's a lot of sex-linked genes. And they are usually caused by recessive alleles, which means big case or little case?
Little.
Little, very good. Since males only have 1 copy of the X chromosome, they will have the disorder if they inherit just 1 copy of that allele. However, ladies in the house, you must inherit 2 copies of the allele? Because we have 2 X chromosomes, right? So if you get one X chromosome that has a recessive disease, you still have the chance of getting another X chromosome that has a dominant healthy trait. Men, you only get one X chromosome, so if that one has the diseased allele, then you have the disease. Because there's no equal trait on the Y chromosome to compensate for it. This is why sex-linked genetic disorders are much more common in males than females. Color blindness, much more common in males. Hemophilia, much more common in males. Muscular dystrophy, baldness, all those things, that is why they are more common in men, because they don't have that second X chromosome to make up for it. So working sex-linked problems, the genotypes for color blindness would be written as follows, okay? This is showing you, the X is showing you that this is on the X chromosome, okay? And the C is showing you that that is the actual trait that we're looking at on the X chromosome, okay? So in this case, big C equals normal vision. Little c would be colorblind, okay? So for this person, X big C would be male or female? Female, very good. And would they have normal vision or colorblind? Big C is normal vision. Normal vision female, right? Because it's big C, big C. And XX means female. How about X big C, X little c? Is it a man or woman? Woman. They have at least one big C, so they would have normal vision. Very good. Normal vision female, but a carrier of the colorblind allele. Okay? A carrier means that you are somebody who has that diseased allele, but you don't show it. I have normal vision even though I could pass off a colorblind allele to one of my kids. I actually don't know that for sure. Who knows? I could be. You could be a carrier. Any of the girls in here, we could all be carriers. Men, sorry, doesn't work that way. Okay, XX little c. What would that be? Male or female? Female and colorblind. Very good. Which means she got one from her mom and one colorblind gene from her dad. X big C Y. Is that male or female? Male. Big C means what kind of vision? Normal vision. Very good. X little c Y. Man or woman? Male. What kind of vision? Colorblind. Very good. You see how these look a lot harder, but they're not? Hopefully they're not. So here's another example using hemophilia, okay? Let's see if you guys can take a second and read those. Is there one more? Yeah. So let's see if we can go fast this time. First one. Remember, hemophilia is a recessive trait. Okay, so the first one is female and normal or hemophilia?
Normal.
Perfect. Normal female. Next one, male or female?
Female.
Normal or hemophiliac?
Security.
Excellent. Normal, but she is a carrier. Very good. Next one, male or female? Female. Normal or hemophilia? Perfect. Next one, male or female?
Male.
Male. Normal or hemophilia? Very good. Last but not least, what's our last one?
Male.
And
Hemophilia.
so I really want to drive home to you guys, the only time that you see this kind of notation is if it says it is a sex-linked trait. It will always tell you this is a sex-linked trait if it is one, okay? Then you know you have to do the X and the Y thing. Otherwise, it's just letters. Are we cool with that concept? Okay? All right. So let's look at a practice problem. A normal woman whose father had hemophilia married a man. What is the chance of hemophilia in their children? So a normal woman whose father had hemophilia, what is she going to be?
Carrier.
Excellent. How do you know she's a carrier?
Because
Oh, wait, I'm sorry. This was the woman's father, right? He had to be X little h y. So like you guys said, she had to be a carrier. She had one big H because she is normal, and she got the little h from who?
her dad.
Her dad. And she had to get that little h from her dad because that's the only X chromosome he has to give, right? What is the genotype of the man? A normal man. X, big or little h? Big H and Y. Very good. X, big H, Y. So now we could do the Punnett square, right? So there's the woman, there's the man, here's their babies. Okay. What is the chance of hemophilia in their children? What is it? What percent is that? 25%. Is this starting to make sense to you guys? Are you feeling like you could kind of do this?
Maybe.
So the genotypes, we know we have these different ones. You guys are pretty good at this by now. Okay. Go back. Sorry. You guys. I just wanted to show you an example of color blindness. Okay, so the gene for color blindness is carried on the X chromosome and is recessive. A man whose father was colorblind. We won't go through this because we just did an example very similar to this. My husband's actually colorblind. So when I asked him to look at these, he could see the 45, but he can't read page 5, he can't see the 3, and he can't tell that that's red and pink. Like those all look like gray boxes to him. Just kind of crazy, right? I bought him those Enchroma colorblind glasses, and he was like, red is the brightest color I've ever seen. Just kind of funny. So yeah, that would be red-green colorblind. All right. Here's what we're going to do. For your Flintstone worksheet, I'm going to say just do the front side, okay? Front side only. Front side only. All right, that'll give you guys a little bit of time in class to work on it now. Finish just the front side, and I'll give you guys time to work on the back side tomorrow in class. Sound good? All right.